Jai Hind everyone. Myself Pooja Sharma. I am Assistant Professor in Computer Science and Engineering Department in Ajay Kumar Gar Engineering College. In today's lecture, we will discuss about the MapReduce. So these are the contents we are covered in today's lecture. First one is traditional approach. In this topic, we will discuss how distributed and parallel processing work in traditional approach. Second will be challenges. What challenges we have faced when perform parallel processing in traditional system. Third will be fundamental of MapReduce. Fourth is example of MapReduce. Fifth is advantages of MapReduce, and last one is developing a MapReduce application. Now, the fundamental of MapReduce. MapReduce is a core component of Apache Hadoop. As we know, SDFS will store the large amount of data in distributed form. Now, how data will be processed, or we can say that who will give information on retrieve information from that stored data. This task will be done by processing unit. So, we need that kind of processing unit that process the stored distributed data in parallel form. So, MapReduce is especially designed for this purpose, or we can say that it is the processing unit of SDFS. MapReduce perform the processing of large data set in distributed and parallel manner. Now, before discussing MapReduce briefly, we will see how distributed and parallel processing work in traditional system. Okay. Let's see one example. Here, I want to calculate the day having the highest temperature each year, where I have a weather log containing the daily average temperature of the year from 2019 to 22. In traditional way, firstly we split the data into smaller parts or blocks and store them in different machines. Then find the highest temperature in each part stored in corresponding machines. At last, combine the results received from each of the machine to have the final output. This will be the final output. When we perform distributed and parallel processing in traditional system, we face some challenges. First challenge will be critical path problem. It is the amount of time taken to finish the job without delaying the next milestone or actual completion date. So, if any of the machine delay the job, the whole work get delayed. Second challenge will be equal split issue. How we will divide the data into smaller chunks so that each machine get even part of data to work with, or in other words, how equally divide the data such that no individual machine is overloaded or underutilized. Third challenge will be the single split may fail. If any of the machine fails to provide the output, we will not be able to calculate the result. So, there should be a mechanism to ensure this fault tolerance capability of the system. Last challenge will be aggregation of the result. There should be a mechanism to aggregate the result generated by each of the machine to produce the final output. So, these are the issues which we have to take care individually while performing parallel processing of huge data sets while using traditional approach. To overcome these issues, we have the MapReduce framework. Now, MapReduce framework. MapReduce is a programming framework that allow us to perform distributed and parallel processing on large data set in a distributed manner. Okay, MapReduce basically consists of two distinct tasks, map and second one is reduce. Okay, or we can say that there is one class called mapper class and another one is reducer class. Okay, basically they are work on divide and conquer approach. As we know that in divide and conquer approach, we divide the large amount of large problem into a smaller problem and then combine the output of these smaller problems to give the final result. So mapper will divide the large data into smaller blocks. As the name of MapReduce suggests, the reducer phase takes place after the map phase has been completed. And the output of mapper or map job is input to the reducer. The reducer receives the key value pair from multiple map jobs, and then reducer aggregate those intermediate data or intermediate key value pair into a smaller set of tuples or key value pair, which is final output. Okay, basically there are two essential dimensions of MapReduce. First is job tracker and second one is task tracker. Job tracker and task tracker. Job tracker schedules the job, provide the resources to task tracker and monitoring all the tasks. All the work that will be assigned by job tracker done by the task tracker. Okay, this one is in MapReduce. And these two work in SGFS. Okay, data will be stored in distributed form. We can see that data will store in distributed form. There are 4 nodes where we store the data. Okay, if we want to run any program in traditional system, then firstly it will it called by a processing unit, then it will be run. But in MapReduce, task tracker will work on every single node. There is a one node where task tracker will perform processing, and there is second node, task tracker will perform processing, there is third one and fourth one. Okay, this data is stored, these data are stored in locally, not remotely, because we know that propagation delay is equals to distance upon velocity. Distance upon velocity. It means propagation delay is directly proportional to the distance. If we store data remotely, then access time will be increased. So propagation delay is also increased. Now we will develop an MapReduce application. Then we create a 3 classes called mapper class, second one is reducer class and third one is driver class. So first one is mapper class. The first stage in the data processing using MapReduce is the mapper class. Okay, first is input split. Basically, it is a unit of work in MapReduce program that can be processed by a individual map. In other words, input split represent the data to be processed by an individual map. Each split can be divided into smaller segments known as record. Split implementation extends the input split class, which is a base abstract class of Hadoop. It is already defined in Hadoop. it is able to define split length and split location. Okay, length is basically length, how much length will be of a given word, and location where the block will be stored. Okay, and this will be the map input split method. Public abstract class input split. There are two. First one is get length, second one is get location. From get length we get the length of a block, and from get location we get the location of a particular block. Okay. Next one is record reader. As we know, the input split defines the unit of work in a MapReduce program, but the input split does not describe the way to access the unit of work. Here, the record reader process each input record and generate the respective key value pair. Hadoop mapper save this intermediate data into the local disk. Okay, to read the input, the record reader class is invoked continuously until the entire input split are consumed. Each invocation of record reader call the map method of the mapper. Next is reducer class. Reducer class, the intermediate output generated from the mapper is fed to the reducer, which process it and generate the final output, which is then saved in SDFS. SDFS, Hadoop Distributed File System. Next class will be driver class. The major component in MapReduce job is a driver class. It is responsible for setting up a MapReduce job to run in Hadoop. We specify the names of mapper and reducer class along with data types and their respective job name. Now let's see some one example. There is an example of word count. Let us consider a text file called sample text, whose content are as follows: deer, beer, river, car, river, deer, car, and beer. Now suppose we have to perform a word count on the sample text using MapReduce. We will be finding the unique words and number of occurrence of those unique words. Okay, firstly we divide the input data into 3 splits. First one, second and third split. 3 split. This will distribute the work among all the map nodes. Now we tokenize the word in each of the mapper and give a hard-coded value 1 to each of the token or word. It means token will be deer, we give a value 1. The rationale behind giving a hard-coded value equal to 1 is that every word in itself will occur once. That's why we given a value 1. Now, a list of key values pair will be created where the key is nothing but the individual word. It means there is a key, deer, river, beer, car, river. These are the keys. And for the first line, deer, beer, river, we have 3 key value pair. First one is deer 1, beer 1 and river 1. The mapping process remains the same on all the nodes. After the mapper phase, a partition process takes place where sorting and shuffling happen so that all the tuples with the same key are sent to the corresponding reducer. So after the sorting and shuffling phase, each reducer will have the unique key and list of values corresponding to very key. Okay, from in shuffling phase we get this result. यहाँ पे हमारे पास तीनों नोट से मैप से हमने जो डेटा लिया है, वैल्यू कुछ इस टाइप से आएगी: बियर कॉमा 1, बियर कॉमा 1, बियर कॉमा 1. keys are same, that's why we are written this into this form. Okay. Now reducing phase, after reducing phase we get the final output beer 2, car 3, beer 2, deer 2, river 2. Okay. Now each reducer counts the value which are present in the list of values. As shown in figure, reducer get a list of value which is 1 1 from the key beer, then it counts the number of ones in very list and give the final output as beer 2. Finally, all the outputs key value pair are then collected and written in the output file. This is the final output and it is written in output file, output.txt. Okay. So, we can see that example, this is an example of MapReduce. Okay. Now, the advantages of MapReduce over traditional system. In first one is parallel processing. In MapReduce, we are dividing the job among multiple nodes and each nodes work with a part of the job simultaneously. So, MapReduce is basically based on divide and conquer approach. We already discussed, which help us to process the data using different machines. As the data is processed by multiple machines instead of single machine in parallel, the time taken to process the data get reduced by the tremendous amount. Okay, in this diagram we can see that in traditional approach data will be moved to the processing unit, means data will move towards the processing unit. But in MapReduce approach, processing unit will move to the data. Okay. So, a second advantage will be based on this. Data locality. Instead of moving data to the process unit, we are moving the processing unit to the data in the MapReduce framework. In the traditional system, we used to bring data to the processing unit and process it. But as the data grow and become very huge, bringing this huge amount of data to processing unit pose the following issues. First one is moving huge data to processing is costly and decrease the network bandwidth. Okay. Second one is processing takes time as the data is processed by a single unit, which become the bottleneck. Third issue will be the master node can get overburdened and may fail. Now, MapReduce allow us to overcome the above issues to bringing the processing unit to the data. The data is distributed among multiple nodes where each node processes the part of the data residing on it. This allows to have the following advantages. First is it is very cost effective to move processing unit to the data. The process time is reduced as all the nodes are working with their part of the data in parallel. Every node get a part of the data to process and therefore there is no chance of a node getting overburdened. At last, we discuss how we develop a MapReduce application. The entire MapReduce program can be fundamentally divided into three parts. First is map phase code, second one is reducer phase code, third is driver code. Now, mapper code. Mapper code, this is the mapper class. Okay. First, we have create a class map that extend the class mapper, which is already defined in MapReduce framework. Okay. In second line, string line equals to value dot to string. We extract the input line one by one. Both the input and output of the mapper is a key value pair. This while loop execute until no token will be found. Now in last line, context dot write value comma new int writable 1. We assign a value to every token. We discuss in our example beer comma 1, car comma 1. That will be the output of this class. Okay, the key is nothing but the offset of each line in the text file. The value is each individual line and the output will be, the key is tokenized word, nothing but car comma 1 is the output. Okay, we have the hard coded value in our case, which is 1, like that. We have written in Java code where we have tokenized each word and assigned them a hard coded value equal to 1. So output will be like this: key and value, key and value. Next class will be reduce class. We have create a class reduce which extend the class reducer like that of mapper. It's already defined in MapReduce framework. Okay, both the input and output of the reducer is a key value pair. Sum will be used as a counter variable. In context dot write key comma new int writable sum. We write the final output, that is key value, key with final value. Okay. Now input the key, nothing but those unique words which have been generated after sorting and shuffling phase. The value is a list of integer corresponding to each key. Output will be, the key is all unique words present in the input file. The value is the number of occurrence of each of the unique word. So this is the final output. We have aggregate the value present in each of the list corresponding to key and produce the final answer. Last class will be driver code. Okay, in driver code, this line create the object of configuration class, and from this line we specify the name of the job, the data type of input and output of the mapper and reducer. Okay, from this line job dot set reducer class reduce dot class and job dot set mapper class map dot class. It specify the name of the mapper and reducer class. Job dot set output key value class text dot class. The path of the input and output folder is also specified from these. Okay. So from this line we specify the path of our drivers. Now in driver class we set the configuration of our MapReduce job to run in Hadoop. We specify the name of the job, the data type of input and output of mapper and reducer. We also specify the name of mappers and reducer class. The path of input and output folder is also specified in driver class. The method setInputFormat class is used for specifying how mapper will read the input data or what will be the unit of work. We have chosen text input format so that a single line is read by the mapper at a time from the input text file. At last, the main method is the entry point for the driver. In this method, we instantiate a new configuration object for the job. So, this is the final code which is written in Java. Okay, this we have defined a class word count. This code will be a mapper class code, and this is reduce class, and this will be driver. Okay, so this is all about the MapReduce. Thank you so much.